Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with episode number 35 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're doing today is we're doing a follow-on lesson to the work that we've been doing in the last 2 or 3 or 4 classes, where we are building a most excellent remote weather station using our Raspberry Pi Pico W connected to an OLED display, and then we've got an RGB LED out here. Now, what we did a few lessons ago, we got the weather station part working, where the Raspberry Pi Pico W goes out to the internet, downloads the real-time weather data to the Pico W, parses that data, and then prints out all the interesting weather data here on the OLED display. So that part was done. But what we wanted to do was not just have this tiny text on the OLED display. We wanted more of a visual indication of temperature on this RGB LED. And so what we've been doing in the last couple of lessons is trying to do the algorithm and the mathematics to allow us to get a really nice and smooth color scale that we could display on this, indicating what the temperature is. Now, what we decided to do was to use the Hue Saturation and Value Color Wheel, this Hue Color Wheel that goes from 0 all the way around to 360. And it's a nice, intuitive, and smooth transition of color. And kind of the thing that we were thinking is, like, we start at 0, we come out here to 60 degrees. Well, at about 40 degrees, we are kind of at this deep violet purple. And that's like what we said, that would be like bone chilling cold, like minus 20 Fahrenheit would correspond to this 40-degree angle. And then as we go all the way around, we go from violet to blue to aqua to green to yellow, and then up to orange, and then up to red. And then we said this red, if we went all the way around to 359 degrees, that would be like blistering hot, like 120 degrees Fahrenheit. So we would go from minus 20 Fahrenheit all the way to 120 Fahrenheit, and then we would smoothly rotate through all of these colors. Now, what we did last week was, I can't just go in and tell the RGB LED to turn to a given hue based on angle. I have to take that hue that we want and I have to convert it to RGB. And we wrote a little library to do that last week, so that part of the job is done. Now what we have to do is we have to take the measured temperature, and then we have to calculate a hue angle that we want based on that measured temperature, and then we take that hue angle and pass it to the library from last week, and then it will return to us an R, a G, and a B value, and then we apply those to the RGB LED. So this is kind of like a multi-week project, and we're just kind of doing that part of it today. So what do we need to do? We need to do today the math that takes a measured temperature and then calculates a position on the Hue Color Wheel here. And so let's kind of talk about what we said that we thought would be pretty good to do. What we said was somewhere here around 40 degrees, okay, around 40 degrees, we would want that to correspond to minus 20F. Okay, so we're going to measure a temperature, and minus 20F would correspond to a hue angle of 40 degrees. Now, as the temperature increases, we're going to come on around this color wheel all the way up to, since we start at 0, we can't go to 360 because that would be the same point. So if we start at 0, we go around to 359, and we would want that to be 120 degrees. So 120 Fahrenheit would correspond to 359 degrees on the color wheel. Okay, now I have 2 points. I need the equation of the line that would then allow us to smoothly transition between all of those different values. Well, what is the equation for a line? Y minus y1 is equal to m onto x minus x1. So the first thing we need to do is calculate slope m, and m is equal to y2 minus y1 over x2 minus x1. Okay, y2 would be 359 minus y1, which would be 40 over 120 minus a negative 20. And so this is going to be 359 minus 40 would be 319 over 120 minus a minus 20 would be 120 plus 20, which would be 140. And so our slope is 319 over 140. Now we've got to come back to the point slope form of the line, and what we're going to have is y minus y1. Well, what is y1? It is 40 is equal to m. What is m? 319 over 140, and that multiplied by what? X minus x1, and x1 is a minus 20. Okay, now this is going to be y minus 40 is equal to 319 over 140, okay, and then that is going to be x, and then we're going to distribute that slope, and a minus is going to be a plus 20 times the slope that we're going to distribute, which is again 319 over 140. And now that all looks good. We distributed that slope, and so now we've got to move the 40 over. So we're going to add 40 to both sides. So we'll get y is equal to 319 over 140 times x plus 20 times 319 over 140, and then plus the 40. Right, now I want to change this to one number, and so I will put that, okay, you'll see that. I'm sorry, it was kind of behind my head, but let's see if I can do that real quick here. I will get out the old calculator, and I will say 20 times 319 divided by 140 is equal to 45.57 plus 40 is 85. We're going to call it 85.6. I'll call it 85.57. So this is 85.57. And 319 over 140, 319 divided by 140 is equal to 2.79. 2.28. So this is going to be 2.28 times x plus, and this is going to be y equal. And now we just need to go in and we need to put in our actual, let's go in and put in our actual variables. Well, what are we trying to calculate? We're trying to calculate the angle, the degree angle on the color curve, and that is going to be 2.28 times x is what? That's temperature. Okay, and then plus 85.57, and that is going to be what we are going to want to program in. Okay, so now I think with that, write that equation down because you're going to need it in a minute. But what we're going to do now is we are going to jump in and start coding. Now, let's see, I think I've got to just review this real quickly. Our schematic here, how we hook this thing up. I got to do that probably before we start coding. And just to look at it real quickly here, you can see we've got the OLED. The VDD goes to this power rail, which is 3.3 volts, which is established over here at the third pin over. That is 3.3 volts down here. And then up here at the third pin over on the top, we established the ground rail. And so ground goes to ground and VDD goes to 3.3 volts. And notice we jumper that from the lower rail to the upper rail. And then the SCK pin goes to the 1, 2, 3, 4, 5th pin over, and the SDA pin on the OLED goes to the 1, 2, 3, 4th pin over. So the SDA is the 4th pin over, and the SCK is the 5th pin over. Now on the RGB LED side over here, this long leg is on the left. It goes to ground. It goes to the ground rail. Now the left leg is the red channel. It goes through a 220 ohm resistor, comes over to GPIO pin 16. And then the green leg to the right of the long one goes to through a 220 ohm resistor. It goes to the green channel, which is GPIO pin 17. And then the next one over blue goes through a 220 ohm resistor, and it goes over to pin 18. So red, green, blue go GPIO pin 16, 17, and 18. So that's how we have this thing hooked up. Now, my friend, I think we are ready to code. So let's come over here to the code view. And what we want to do is we want to start with the program that we ended up with in lesson number 32. And that was just the program that goes out, grabs the real-time weather data from the internet, parses the data file, and displays it on the OLED. We don't want to develop that from scratch, and so we're going to go back and get that code that we ended up with in lesson number 32. And so we go to the most excellent www.toptechboy.com, and then using this happy little search tool here, you will search on Raspberry Pi Pico W mobile weather station project. And then we've got this code here that does all the things we want it to do. So I will click copy. And remember, you have to go in and you have to get your API key and you have to do things like that. I explain all of that in those earlier lessons. All right, so you've got to kind of have gone through the earlier lessons, but we're going to come in, we're going to paste that code. Okay, and now let's just run it to make sure that the universe is in proper working order. So I ran it. We come over here. It says it has connected, and then what it does is, boom, it says, welcome to Jinja, my present location. The time is 15:49. That would be 3:29 or 3:49. That is the time. The temperature was 74, conditions, clouds, and broken clouds. Let's watch it again. And it gives us the sunrise time, the sunset time. That looks good. 15:49. Yeah, that's 3:49. And then 74.8 degrees, 64% humidity, and all that barometric pressure and stuff. So that is working. That is good news. But now what we want to do is we want to come in and we want to get that RGB value. Okay, we want to get that RGB value and we want to apply that to our RGB LED. So we're going to have to set up the RGB LED. The other thing that we're going to have to do, as I remember, we're going to have to grab that library that converts the desired hue angle to an R, a G, and a B value. And we did that last week. So let's just go. You guys should already have it, but let's just go and snag that library if you don't. Again, at www.toptechboy.com. This time you are going to search on convert HSV to RGB in MicroPython, and you get this little library that we wrote. You click on the 2 pages, and then we're going to come back to Thani, and then I'm going to come up and I'm just going to say new, and then here you would paste it, and now you need to save this as a library. So you would do save as Raspberry Pi Pico. Okay, I got to stop the program. File, save as Raspberry Pi Pico, and you can either save it in this main folder where your existing program is, or you can come down into the library folder and you want to save it as little h2 RGB.py, just like that, being careful of lowercase h2, uppercase R, G, and B, and then .py. Okay, so you save that, and now you have your library. Okay, so now what we're going to want to do is we're going to want to import that library. So we're going to import h2 RGB like that. And now we can do that conversion from the temperature, that we can do that conversion from the angle on the color wheel to the R, the G, and the B value. So we need to import that in order to do that. Now, if we're going to be applying signals to our RGB LED, we're going to need to set those things up. So I'm going to have a red pin, and I'd shown you that that was on GPIO pin 16. We're going to have a green pin, and that is going to be on GPIO pin 17. And we're going to have a blue pin, and that's going to be on GPIO pin 18, as per the schematic that I just showed you. Now we are going to be doing pulse width modulation, so we can be ramping up the brightness of the different channels, ramping up and down the brightness of the different channels. And so we'll need to set up those pins as PWM. And so what I'm going to say is my red LED object is going to be equal to a PWM object. Where is it? It is at pin, which pin? Red pin, like that. Okay. Then green LED is going to be equal to a PWM object. A pin, which pin? The green pin, like that. Okay, now the blue LED is going to be equal to a PWM object. A pin, which pin? Blue pin. So I've created my PWM objects for the three channels, the red, the green, and the blue. And now I need to tell it what frequency I want those PWMs to work at. And we learned that 1000 Hertz is a good one to use. So we will use red LED dot frequency like that, 1000. Green LED dot frequency of 1000, and blue LED dot frequency of 1000. Okay, now we need to make sure that all three of those channels are off. So we're going to say red LED dot duty cycle, the duty underscore unsigned 16-bit number, and I'm going to set that at a duty cycle of 0. That turns the red channel off. Green LED dot duty underscore unsigned 16 is going to be set to a duty cycle of 0. That turns the green channel off. And blue LED dot duty underscore unsigned 16, unsigned 16-bit is going to have a duty cycle of 0. So all those, what is that? 0. So all those should be turned off. I'm going to run it just to make sure that I haven't generated an error in all this stuff that I've been doing. PWM wasn't defined. I need to import that, right? So I'm going to be working with those pins. So from machine, I need to import pin and PWM. I forgot to do that import. Let's run it again. Okay, looks like no errors. And we are going to come over here and see if we are getting a weather report. And yes, we're getting the weather report. So that is working good. Good news is we haven't broken anything. Okay, but now what we need to do is we need to come in and we need to look at the temperature. Now, where do we want to look at the temperature? We come down in this while loop. And in this while loop is where we are measuring and displaying and measuring and displaying. And we do our measurement inside of this if statement. So after you come out of the if statement, you should have your data. Okay, after you come out of your if statement, you should have your data. Okay, and so I need to, from that data set, get the temperature. And how do I get the temperature? Well, it was the weather, this object that I read in here. And then it is weather of, and it was main and then close that, and then it was temp, like that. Okay, now how did I know that? Because we did that a few weeks ago, and you can come down here and see that we got the temperature using that, just like that. So we're doing that same thing this week. I'm just not re-explaining it ad nauseum. All right, now that I have the temperature, I need to convert that to an angle. I need to convert that to an angle on this color wheel, and I do that with this equation here that we just developed. And so what I'm going to say over here is I'm going to say that angle, I will call that angle, I will call it degree, and the degree, that's degree is an angle, that is going to be 2.51 times temp plus 89 point, what is that? I'm sorry, that is, I messed that completely up. I wasn't looking at the equation. So that is 2.28 times temp plus 85.57. And that was from this 2.28, 85.57. 2.28, 85.57. So now I have that angle that I want on the color wheel. Now what I've got to do is I've got to take that angle and I've got to convert that to an R value, a G value, and a B value. Well, luckily that is what this library does that we just put in and we developed last week. So we're going to come down and we're going to call that library. And let's see where we are here. We are here. We have our temperature, and we have our degrees. And now what we are going to do is we are going to come in and we are going to very carefully say that my RGB is equal to that library Hue H2 RGB dot get RGB. That's the method. So it's the library dot the method of what the degree that we just calculated, and that is an angle degree. Now I've got my RGB. It comes in a tuple inside of parentheses, an R, a G, and a B. So we've got to take those out of the tuple, and we do that by just saying the R and the comma and the G and the comma and the B is equal to my RGB. Now that will put them in those individual values. All right. Now what I need to do is I need to take that R, that G, and that B, and I need to apply it to the RGB LED. Now those RGBs are between 0 and 1. They're an arbitrary scale between 0 and 1, but the pulse width modulation in the Raspberry Pi Pico W wants a 16-bit number. That is a number between 0 and 65,535. So I've got to take my R and my G and my B, and I've got to multiply it by the 16-bit number, 65,535. So I'm going to say red LED dot duty. This is going to apply the signal to the red channel. Okay. Underscore unsigned 16 is equal to that number R, which is a number between 0 and 1, and then we convert it to a 16-bit number by multiplying by 65,535, like that. Okay. And then the green LED dot duty underscore unsigned 16 is going to be, you guessed it, G for the green channel times 65,535. Close that, and then blue LED dot duty underscore unsigned 16, and that will be blue B times 65,535, like that. And so now I've applied those values to the LED. Okay, and so now what that should do is, if it's blisteringly hot, we should be getting something that is bright red. And if it's 20 below, I should have something that is deep violet or deep purple. And then if I've got something that is a nice pleasant temperature, it should be green. If it's getting warm, it should be going yellow to orange. And if it's getting cool, it should be going from green to aqua, turquoise to blue. And then as it starts getting really cold, it should start going to purple, if that makes sense. So I don't know, I might have an error in here, but let's come over here and let's run this. And I will come here, I will run this, okay. And then we will come over here and we will put the little cap on there to make it a little bit easier for you guys to see. I can't convert float to int. I know what that was. All right. Now these duty cycles have to be integers, but if you remember when we were calculating our degree value, that was based on a slope that wasn't an integer. And so these things are probably going to be floating point numbers because of the algebra we did. So just before we apply them, we need to convert them to an int like that on all three of them. I forgot to do that. But you couldn't apply a duty cycle of, 32,550.46752. It wouldn't like that. So we've got to lop off and make those ints. Okay, now let's try running it. And that looks happy so far, so good. Okay, so we'll come over here. And now let's see what happens. All eyes on the screen. And boom, look at that. Oops. And I have one other error in here. I got an error. Hopefully you guys saw that. On this unsigned int, I put an uppercase U. It should have been a lowercase u. So let's try that again. This time I think it should run. And we are at, let's see if we can catch the temperature when it comes by here. And we are at 70 on the next screen. We are at 75 degrees, and 75 degrees is beautiful weather. It is green with just a little bit of yellow indicating that it is getting a little bit warm. But you see, this is just perfectly calm, perfectly pleasant. Well, I can't go outside and change the temperature. So what we're going to cheat a little bit and just see if our color scale is working well. We're going to see if our color scale is working well. So here where we grab the temp, I'm just going to cheat and change it. So let's say if the temp was equal to 60 degrees. Okay, what's it going to look like if the temp is equal to 60 degrees? We'll come over here. Okay, and for 60 degrees, what we see is, look at that. It is turned a little bit aqua. So it's still pleasant, but the green has shifted to aqua. So the pure green is like perfect comfort around, around 70, 75. And then as we go from 70 to 60, we start mixing that blue and that cold in, and that aqua is indicating maybe you might want a jacket, okay? Well, what if we went down to 40 degrees? Now, 40 degrees is actually getting cold, right? 40 degrees, you actually are going to notice that is cold. And so at 40 degrees, what we see is we come over here, and at 40 degrees, boom, it is really blue. Okay, it is getting very blue there. Not much green in it anymore. Okay, so let's make it freezing. So let's say it was 32 degrees. And we'll run that, see what that color looks like. And you guys can play with the limits on your color a little bit, but I kind of like this. To me, it's pretty intuitive. At 32 degrees, which is freezing, it is like pure blue and probably starting to head towards purple already. And now we'll come in. What if it is absolutely 0 degrees? That is getting really, really, really cold. Let's run that, come over here. Okay, and that is purple, right? That is saying put on your heavy coat. And then finally, let's just say it should work at -20. Let's see if I didn't do, it might have a round off error or something that might not like -20 to go absolutely to the end, but let's look and see what happens. So at -20, what we see is we have at -20, we have bone chilling purple deep violet, okay? And the last one that I'll try is, let's just say that it was, let's say it was 105, 105. Definitely at 105, we don't want to see a pretty green. We want to start seeing yellow and orange coming in there at 105. Okay, yeah, look at that. That yellow to orange is showing at 105 you are really, really hot. And then if we put in 120, it would just be completely red. Okay, I really like that scale. I think that works pretty well. And then let me show you what is really neat about that. We can come over here, and what we can do is I can now save this. I can say save as. Okay, I got to stop the program. Now I can say save as, and I can save this as main.py like that. Okay, and now let's look at what we can do. Now what I can do is I can disconnect this completely, and I can bring my battery in and this little power board, and I can plug it in as such, and then this thing should boot up and running completely mobile, untethered. What I'm going to see is, hopefully this thing will come to life. Boom, look at that. So what I see is that it is a temperature of 75 degrees. That's a nice green, but beginning to, you know what? I lied. False alarm. What did I forget to do? I thought that is really looking yellow for such a beautiful, lovely day. What did I forget to do? Somebody tell me. Okay. What I forgot to do over here was I forgot to take that out and just use the measured temperature. And so now we will come over here and I will save it again as main. Okay. I will save it as main. All right, and now that is saved as main, so I can unplug this. And now I can plug the little power board in here like that. And now this thing should boot up. And this time it should really be at 75. It should really be kind of a sweet spot of green, just like perfectly comfortable green weather. You know, not really warm, not really cool, and boom, look at that green. And what do we see? We are completely mobile. We have a mobile weather station with an OLED display and then a nice sort of visual display of the color based on the temperature. Okay, guys, that, I don't know. I am having a lot of fun with this. I hope you guys are having as much fun taking these lessons as I am making them. Okay, I just think that this is really neat. What I like about it is it's self-powered. I like the little display that you can get all the data on. And then I like the LED that just gives us more of an analog feel, more of a qualitative feel for what the temperature is. I hope you all are enjoying taking these classes as much as I am making them. If you enjoyed the class, give us a thumbs up. Also helps us with the old YouTube juice if you'll leave a comment down below. And I want to give a shout out to you guys who are helping me out over at Patreon. YouTube hasn't been showing me a lot of love, and so you guys that are supporting the channel and standing with me through the Patreon support, really appreciate it. Also, if you haven't subscribed to the channel already, subscribe. When you do, ring that bell so you'll get notifications when future lessons drop. And as always, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.